So let's discuss today's question. So in the question you are given an 2D array classes in which every element describes the class, like the number of students in the class and the number of students which passed a particular exam in a class. Okay, so yes, and also you are given extra students variable, okay, which is the number of students which are like extra, and they are brilliant, so like they are guaranteed to be passed. Okay, so now you have to find like the uh, average pass ratio across all the all the class. You have to actually maximize it. Okay, so let's take an example and then understand the question. Like this is the classes array. So in the first class there are two students and one is able to pass. In the second class there are five students and total five students and three passed from the class. And in the third class there are a total of two students and two passed in the class. Okay, and now you have to tell that adding the students in which class will give the maximum average pass ratio, okay, across all classes. Actually you have to return that maximum average pass ratio. So what is maximum average pass ratio? Like for let's for a moment forget this, the extra students. So what will be the average pass ratio of these classes? So that will be the ratio of 1 divided by 2, 1 divided by 2 plus 3 divided by 5 plus 2 divided by 2 divided by 3. So basically I will write this here, 1 divided by 2, okay, then plus 3 divided by 5 plus 2 divided by 2. Okay, so yeah, divided by 3. So the number of classes, okay, so the ratio of all the classes divided by total number of classes, this will be the answer if we would have not given the extra students. Okay, so this is the average pass ratio across all the cases. We have to maximize this value. So we can add that extra students to any class. Like first like one student can be, we can add one student here, we can add one here. Okay, so maximum we can add only two students to the yeah, classes. Or also we can do anything like we can add a student here and then here. So yeah, just we have to add anyhow, but at the end the ratio should be maximized. This average pass ratio across all classes should be maximized. So yes, so like the main question is like how will you add, like where to add the student, extra student in the class? How will you get to know that? Obviously you can see like if average, like we have to maximize the average. So what we can do, like at every point, like we have to add like n students, okay, extra, sorry, extra students we have to add. So like first we will try to add one student. If we have to add now one student in any of these classes, three classes, to where we should add that student so that the average is maximized. So what we'll do, we will first try to see like that adding this student to this class will give the average max more, or adding the student to this class will give the average more, or adding the student to this class will give the average more. Obviously adding anywhere will give will increase the average, but adding to which class will increase the average to more, we want that. Okay, so like we can then see that if we like add um, one student to in this class, so our what we'll get, the ratio for this class will become like, now how much. Mm, like we have like three possible cases in this here. Let's add in first class. Okay, first class. So yeah, so the now average will become uh, 2 by 3 plus 2 by 5 plus 2 by 2 divided by 3. Okay, so you can see here like yeah, we have added the student in the first class, therefore total number of students also increased by one, and the number of student passed also increased by one because we have added one student. Okay, so the first case will be this. Okay, second case will be what, like you are adding the student to the second class. Yes, so then in that case uh, yeah, the thing like this will become 3 and this will become 6. Okay, and we will calculate the average. And in the third case what will happen, this is 1 by 2 and this will remain same and this will become 3 3. Now in whichever case, like we will try to add in every class and check which is giving the more average. Okay, now whichever will give the will give us the more average, we will add the student in that class. Okay, so this is for one student. Then again we will do for this another student. Like so for all extra students we will try to add them in such a way that it is maximizing the average. Now if you do that brute force, like you apply brute force in this, then it will go like n square, now like extra students multiply by classes dot n, because every you are checking for every class that how much it is increasing, the average is how much the average is increasing. So that is not possible, so we have to do come up with a solution such as n log n, like n log n. So we want a data structure which will give us the class in which we should add the current student, so that the average will increase. Okay, so for that we can use priority queue. Okay, so we will the priority queue will store all the classes, and it will return the class in which if we add the current student, then current extra student, then our average is increased. Okay, so the priority queue will return us. Okay, let's try to code it, and then I will explain it to you simultaneously. So first, let's calculate the average. Okay, so let's name it as t average. Okay, t average is equal to 0. Okay, and now for int I is equal to 0, I is less than classes dot length I plus plus. Okay, so average t average plus ratio. Now we have to calculate the ratio. So it would be, yes, first let's convert it to double classes of I comma 0 divided by double classes of I comma 1. Okay, so here we have calculated the average ratio across all the classes. Now we'll define a priority queue. Priority queue pair pq is equal to new. Okay, so we will try to push all the classes in the priority queue. So let's push it. Pq dot add new pair. Okay, and yeah, first we'll push the number of students which has passed. I will define the pair class just a moment after. I0 comma classes of I1, the total number of students, and t average, which is the current average, if current average like of all the classes. Okay, so across all the classes. Now I have pushed all the elements. Now let's define the pair class. Okay, so first in p, the number of students which passed the thing, like the exam, then total number of students. Okay, and the current average. Okay, let's take it as input as a constructor in p, in p double average is not p, this dot average is equal to average. Okay, yes, I've taken the inputs, and now we have to define our priority queue, like how will it uh, order the elements and return. Let it implements. Yes, so in this function we have to write uh, which element will come first, like which in the order, like to which we have to add the extra student. So public int, yeah, compare to. So we will compare every element. Okay, so this is the code for that. So we will compare compare this with p2. So in internally priority queue will do all the comparisons and return it to us in login with us. Okay, so what comparison we have to do? So yeah, first we'll calculate that if we have two options. Okay, uh, first is add like not element, student in this class, or add in p2 class. So which will what thing will decide it? So the average, if like we will first we'll do what, we'll add the student in first class and calculate the average then, and then we will add the student in p2 class and also calculate the average. Whichever average will be more, we will return that class. Okay, yeah. So like in the first case, I'm naming it as like first calculate the ratio. So the ratio, ratio which was before. ratio before, it was how much? So it was like yeah, we can copy it from here. Classes of not classes, this would be p upon t. This is the ratio. Okay, actually this dot p and this dot t. So this was the ratio before. Okay, and ratio after adding one element in this class will be ratio a, and that will be this p plus 1, because we have added one student, so it will increase by 1. Yes. So yeah, now the we have calculated the ratio. Now the new average for the, if we add in this, it would be double new average. This would be how much? The total average, which was which we have given to every class. So this dot average minus the before average, sorry, the before ratio, plus the added ratio. So we have to, like, from the sum we have to subtract that also. And actually this is not average, we have not divided it, the average by the number of classes, we have just summed up all, because at the end, yeah, we have to maximize. If we will maximize the sum of all the ratios, then eventually we are maximizing the like like we can divide it by n. Okay, so if the number is greater, and if we divide it by n, obviously we will get the more greater average. Okay, instead of the small, if we divide the smaller element by n. So yeah, we if we are able to maximize the sum of ratio also, then also it's okay, and at last we can then return just this t average divided by classes dot length, which is the number of classes. Yeah, so we will just subtract it for before ratio, and after ratio we will add it. Yeah, now this is the new average in the first case. Okay, so this was the first case. uh, yeah, and now we will do it for the second case also, which is that adding student in the second case. Add student in p2, in p2 first case, add student in this. Okay, yes. So in the second case we will add it. Yeah, so what we can do, we have to calculate the same thing for the second case also. So let's not reinitialize it. Yeah, so here, this, instead of this dot p, it will be p2 dot p. Control c, and same here and here, everywhere it will be same, because we are calculating for p2. And yeah, the new average, let's name it as average 2, and name this as average 1. So this will be also okay. Yeah, this is okay, like everywhere it will be same only. This dot average minus ratio b, yeah, ratio of a. So I'm again calculating this ratio b and ratio a for p2, and then I'm adding it. So this will be different than this. Okay, yeah. So yeah, now the new average, we got both the averages. Okay, now we will just if new average 1, which is for this class, this is less than new average 2, we will just return 1, and else we will return minus 1. Okay, yes, we will return minus 1. Yeah, so this will give us the what we can say, yeah, this will give us the class in which we should add the current student, one student, so that the average, total average will increase. Okay, so now we will just first of all let's name this as es, so that we have to don't write the big name every time. Yeah, so while es, which is extra students, is greater than 0, what we will do, uh, we will just yeah, we will just add that one student to that particular class, and increase our t average. So where current is equal to pq dot remove. Okay, now what we will do the same thing here also. We will, because we have to increase the ratio, sorry, yeah, average. Yes. So yeah, here instead of this, it would be current. Yeah, this would be t average, and this would be t average, because we are updating t average, which we have defined here and calculated above. Yeah. So now, yeah, we will update the t average, and we will just uh, add the new thing, because we will update every class, and we will add it again to the priority queue, so that if a class needs more than one student, then it will get it in future. Where here we have to just write current dot p plus 1, because the number of past students have increased, and obviously current dot t plus 1, number of total students also has increased by 1, and the t average is also updated. Yeah, and we will decrease the is minus 1, we will decrease it, and at the end we will just return t average divided by classes dot length. Okay, yeah, this will give us the average pass ratio across all the classes. Let's try to run it. Okay, okay, so what's the error? Semicolon. Yeah, it's getting accepted, like it's running fine. Let's try to submit it. Yes, it's getting accepted. Okay, thank you all for watching.